So guys, welcome to the lecture 15 part 1 and topic is a dynamic programming. This is the important topic for the high paying job. So if you want to crack high paying job, then this topic is for you. So we start now. So first, what is a dynamic programming? So dynamic programming is a optimization technique used to solve complex problem by breaking them into the smaller overlapping subproblem and solving each subproblem only once, storing its result for the future use. This avoids repeated commutation and reduces time complexity. So, key characteristics of dynamic programming. So, one for the first one is a overlapping subproblem. So, the problem can be break down into the smaller subproblem that are reused multiple times. Example for Fibonacci series. And second is a optimal substructure. The optimal solution of the main problem can be constructed from the optimal solution of its subproblem. Example, sorted path in a graph. Now come to the approach of the dynamic program. So basically we have two approaches. So first one is a top-down approach and you can say memoization. And the second is a bottom-up approach and you can say tabulation. So first we discuss top-down approach. So memoization also can be say. So first we discuss top-down approach. So this one basically use a recursion plus cache. Cache is a basically used array or map to store already computed result. So this is the example you can see for the Fibonacci series and time complexity for this code big op n and space complexity also big op n for the stack and DP array. So now come to the second one. Second one is a bottom up approach. So solve iterative from the base case and store intermediate result. Example for the Fibonacci series. So first we initialize our vector of dp with n plus 1 size and initialize with the 0 values. So this is the code for the Fibonacci. So this is the code for the Fibonacci series. You can see and time complexity for here and time complexity here you can see big op n and space complexity is also big op n, but it can be optimized to the big op 1 also. So now come to the types of the dynamic programming problems. So Fibonacci series. Second is a knapsack. Third one is a subset and partition problem, matrix based DP, string based dynamic programming, DP on trees or graph, bitmarks DP, DP on subsequences, DP on grid, DP on digit. And here common pattern we use in the dynamic programming. So 1D DP problem involving linear recursions like Fibonacci series and stairs, and 2D DP problems involving two sequences on the grid like LCS and matrix path, and 3D DP advanced problem like knapsack with constraint. And advantage of the dynamic programming is a reduce exponential time complexity from 2 की power n to the 2 की power n square or big op n. Disadvantage of the DP high space complexity. If large DP array require understanding of the state definition and transition. Common step to solve DP problem. So identify overlapping subproblem and optimal substructure. Second is define the state, and third one is write the recursions relation, and fourth one is choose approach, memoization or tabulation, and fifth one is handle base cases, and sixth one is implement and optimize by using space optimization if possible. Here you can see the popular example of the dynamic programming. So first is a Fibonacci series, second is a climbing stairs, third one is a knapsack, and fourth one is a coin change, minimum or maximum base, longest common subsequence, added distance, and last one is the longest increasing subsequence. So this is a popular example of the dynamic programming. I think this one is clear to you. Thank you.